Welcome to the first video in a series of videos designed to explore the exciting world of quadratics. In this video, we will look at the general form of a quadratic, talk about the first step we always need to take when we're examining a quadratic. We will determine the coefficients of a quadratic and talk about the general graph of a quadratic. And finally, we will discuss what the leading coefficient tells us about that graph of the quadratic. So to begin with, the general form of a quadratic can be written as ax squared plus bx plus c equals 0. The part that makes this a quadratic is having an x squared term. Okay? If all we have is an x term, all right, or a coefficient, then we don't have a quadratic. And if we have a higher power of x above 2, then we don't have a quadratic. So what we're looking for is x raised to the second power, and then we have a quadratic, as long as there's no other higher powers of x. Notice that in my general form, I have the quadratic equal to 0. So that is always going to be our first step when we want to examine a quadratic. If I take the example I've given here, x squared minus 9x plus 10 equals negative 8, I see that my quadratic is not equal to 0. The way I set it equal to 0 is by adding 8 on both sides of the equal sign. Okay, and now my new quadratic is x squared minus 9x plus 18, because 10 and 8 is 18, and on the right hand side I have equal to 0 because a negative 8 and a positive 8 equals 0. Now I'm ready to determine what my coefficients are. The coefficients are defined as a, b, and c. And if we go back to our general form of the quadratic, I see that a is the coefficient associated with x squared. In this case, I see that I really don't have one written there, but 1 is implied, so a is equal to 1. B is the coefficient associated with x. In this case, I see that in front of my x, I have a minus 9, so that is my B coefficient. And finally, C is the constant added on to the end. Here, I see that I have plus 18, so my 18 is my C coefficient. Now, the general graph, if I were to plot this or plug values in for x to generate y, is the shape of a horseshoe, either pointing up or pointing down. We call that a parabola. All right. Our leading coefficient a, which in this case is a positive 1, tells us whether or not our parabola will point up or point down. If a is greater than 0, that's just fancy math speak for a is positive, then our parabola points up. If a is less than 0, again, fancy math speak for a is negative, then our parabola points down. Tune in for our next video where we will discuss the vertex or the turning point of the parabola.